All right, so pick it back up from where we were. We're on back now. And so we're now going to try to solve using that distributive property. So again, make sure that you can see these are two different sides of an equation. So you should only be working on one side at a time. Again, if you do inverse operations, you want to make sure that you are doing performing those inverse operations to both sides. So usually also what I have been writing down, I got this from one of my students my first year here. I believe it was one kid named Daniel. He brought it from another school and he said, "Hey, Miss Shank, let me show you something." He said, every time I see an equation, I write DCM next to it. And what that stands for is I have my distributive property, I combine like terms, and then I have my, I manipulate the variable, which just means you are dividing by that coefficient. And he said that's kind of the order of operations for when you're solving equations. So every time you see an equal sign, just go ahead and write that DCM. That way you can kind of check it off as you go along. So that means that we need to do distributive property first, then we combine like terms, then you have your multiplicative inverse. So let's do the distributive property. So I'm going to do, on the outside I have 3, and then that x plus 4. So I have 3x, and I have a positive 12. Again, I write that below, so I have 3x plus 12 equals 30. Again, now I can draw my railroad tracks, river, training wheels, whatever you want to call them. And can you help me out? Sure. Please and thank you. Nicholas, if this is my equation, thinking back to last couple days, if this is my equation, 3x plus 12 equals 30, what would you like to do as your first inverse operation? Sounds good to me. So let me get up my opposites, or my inverse operations. So, like you said, I'm going to subtract 12 from both sides. Again, this cancels out on the left. The 3x comes down, and I have 30 minus 12 is 18. So again, we did distributive property. All of our variables are on the one side, all the constants are on the other, so that means we combined like terms already. And now we just manipulate the variable, which means we just divide by the coefficient. So can you help me out, please? Sure. Christian, what would you like to divide by? 3. Very good. So I'm going to divide both sides by 3. Again, this cancels out, so I have 1x equals 6. Again, to check, I'm going to plug in the value x equals 6. Again, you can use this on the Desmos calculator, or you can show your work like this. You can say 3 times quantity, and then I have, instead of an x, I now have a 6. So that would be 6 plus 4. And we're saying, does that equal 30? So does that equal 30? That's what that question mark is there. So we're trying to see, is this true? Well, we would say, okay, this is going to be 10 times 3. Is that 30? Well, yes, 30 equals 30, and so we know we are good. Make sure that you can check each time for yourself, so that way you know how to solve. And that other one, or the next one, excuse me, again, I can have my distributive property first. So I have my DCM, so I'm going to do distributive property. 4 is going to be on the outside. Then I have positive x and a positive 3 on top. Kind of draw the signs if you need to remind yourself. 4 times x is 4x, and then 4 times 3 is 12. Again, write that right below. So I have 4x plus 12 minus 8 equals 0. All right, so now, sure. Lowell, can you help me out, please? If I'm looking on the left side of this equation, is there anything that I can combine that are like terms?
Negative 12 and 8. Negative, no. Positive 12 and negative 8.
I got what you're saying, yes. So he's saying let's combine these constants together. And so what would that end up being?
4.
Sounds good to me. So I'm going to write that below. I'm going to say 4x plus 4 equals 0. Draw your railroad tracks, training wheels, whatever you may call it. Again, I'm going to use my inverse operation. So I subtract 4 from both sides. This cancels out. On the left, we have 4x. On the right, we have a negative 4. Always divide by that coefficient. So we divide by 4 to both sides. And you should end up with x equals a negative 1. Again, to check, you're just plugging it into your original equation. So I'm going to say 4 times quantity negative 1 plus 3 minus 8. We're saying, does that equal 0? Does that equal 0? Again, you can, now when you're doing the check, you just follow your order operations. So it's going to be 2, and we have times 4, and minus 8. Is that equal to 0? Being able to kind of make a prediction and see each of these steps. Again, 8 minus 8 is equal to 0, so we know we are good. Make sure that's erased there. All right. Comments, concerns, questions so far? Last two, and we'll be done. Don't worry, we're that much closer to a break. So it has this. It's going to have, let's do it like this. Let's draw these boxes. So I'm going to have distributive property. And again, I can have it still twice. So I'm going to have 2 times x and then 2 times a negative 3. Same idea of 2 times x and 2 times a negative 3. Write the products inside. So we have 2x and a negative 6 for both of those. And then we just write these terms right below to make an equation. So we have 2x minus 6 plus 2x minus 6 equals 20. All right. Can you please help me out, Emily? Thank you. If we're looking at this equation, I say, let's see, 2x minus 6 plus 2x minus 6 equals 20. Is there any like terms on the left side over here that I can combine? Is there any variables in common? Yes. All right. So what variables do you see that are in common? Okay, so I have a 2x. So let me highlight that. So I have a 2x. And what else do I have? Another 2x. And so what would be 2x plus 2x? That sounds reasonable enough to me. So I have a 4x. Is there any constants that I can combine together? Maybe a negative 6 and a negative 6. Combine those two. Again, make sure you're seeing I'm still on that one side, so make sure you're not subtracting or adding anything to both sides just yet. So my current equation is 4x minus 12 equals 20. Now we can solve like we've been doing. Add the opposite to both sides, so we have plus 12 to both sides. This cancels out. The 4x comes down. 4x equals 32. Always divide by that coefficient. So we divide both sides by 4. And so we end up with 1x equals 8. Always check for yourself to be sure. So we have, for x equals 8, we're going to have 2 times quantity, 8 minus 3. And then same idea, 2 times 8 minus 3. Does that equal 20? So we do, this is 5. And we do, this is also 5. We're going to have 10 plus 10, which, you guessed it, is 20. Everybody okay so far? I know there's a lot of steps going on, but I can assure you, as long as you are following that distributive property, combine like terms, then manipulate the variable, that's all we are doing. Last one, and we can call it a week. If you notice, this is actually from that Unit 4 test, number 8. So I can walk through the example on how to do it. So again, I'm going to help you guys out on this one. I'm going to have, how can I say 1/2 as a decimal?
0.5.
All right, sounds fine to me. So I'm going to say 0.5 times that quantity. So I have 8x on top, and I have a -4 to the side. Let me write this to the side, just to have a little bit more space, just in case. Again, it doesn't really matter where you write on your paper. I'm just trying to make sure I have enough space. So you can add 0.5 times that quantity, 8x minus 4. So I'm saying I'm taking half of 8x, which is 4x, and half of -4, which is -2. Again, write that right below. So I have 4x minus 2 plus 7x equals 108. So now, close this out, please and thank you. Already went. Sure. Maria, thank you for volunteering. Can you tell me, what is there any like terms that could combine on this left side of the equation? All right, sounds good to me. So let's see. I have a positive 4x, so positive 4x, and a positive 7x. What would that combine to be? Sounds fine to me. So 11x. Since there's no other terms that I can combine on this left side, the -2 comes down. And so again, we just have a simple two-step equation. Add the opposite to both sides. So we have plus 2 to both sides. This cancels out. 11x comes down. And we have 110 on the right. Again, always divide by the coefficient, which is 11. And on that quick math times tables, x equals 1x equals 10. Since we can check our answer with our equations, we always want to. So in theory, you should be able to get a perfect score every time you do equations, because you can know that your answer is correct. So let's see. I have 1/2 times 8 times 10 minus 4, and then plus 7 times 10. Again, I'm just using that same equation that I had, I had that same expression that I had from before, but I'm making sure that I am plugging in 10 wherever I had an x. So let's see. Using order operations, I work on the innermost grouping symbol. So I have 8 times 10 is 80. Everything else stays the same. I also did 7 times 10 is 70. 1/2 times 76 plus 70. I believe this is a 38 plus 70. We're saying, is this equal to 108, which is what we were given, which it is, and so we are good. Again, make sure that you're asking questions for yourself. If you're still having difficulty with the combining like terms, meaning if you're struggling from where I highlight to where I get my result, please do draw the picture. And be sure to slam the subscribe button.